Okay, today we're going to talk about polynomials, and basically, maybe you might recall this from Algebra 1 days. We're going to talk about foiling. And when you're working with polynomials, you need to know, first of all, in 7.1, that a polynomial is an expression that is the sum of terms containing variables with different powers. So maybe it would be helpful to see an example of a polynomial. So for example, something like 5x squared minus 3x plus 7 is a polynomial. A term is a piece of the polynomial separated by a plus sign or a minus sign. For example, in the above example of a polynomial, negative 3x is one of the terms. And then the last part of our vocabulary is the degree, and that's the highest power in the polynomial For example, in the one above, the answer would be 2. That's the power of the polynomial, because the highest power you see in the red polynomial, 5x squared minus 3x plus 7, is 2. That's the degree. General form means to write something from highest power to lowest power. So write the polynomial from highest power to lowest. So for example, in this particular polynomial that we see, we look for the highest power, we see that it's a 5, so I would write down 3x to the 5th, and then I look for the one with the 4 power, so that's minus 8x to the 4th. Then the third power, I see positive 3x cubed, and then I see 2 squared, so I put them together, minus 9x squared. That's called combining like terms. And then I also see 2 numbers, and I put those together, and that's minus 4. So if you're wondering where those things came from, the 5x squared and the minus 14x squared is what gave me negative 9x squared, and the negative 12 and the positive 8 is what gave me the negative 4. So I'll refer to the next part of the process as awful or FOIL, either one. And most of you have heard of this as FOIL, so I'll start out with the word FOIL, I guess. Oopsie. So the big idea is when you see parentheses that are being multiplied together, you use something called the distributive property, which we use an acronym of FOIL to talk about first, outer, inner, and last multiplication. So if I multiply the first terms, x times x, that's producing the x squared. If I do the outer terms next, that's x times 6, which is 6x. And then I do the inner terms, which is 3 times x, that's positive 3x. And then I do the last terms, which is 3 times 6, which is positive 18. Of course, at that point in time, you're supposed to combine the like terms, which means all the things that are x's put together in this particular problem. So that's x squared plus 9x plus 18 as your final answer. So those like terms in this particular problem were the fact that we had the 6x and the 3x, and that turned out to be 9x. Thank you, Daniel, for the help. In the next one, my first times first is x squared. Outer is minus 3x. Inner, positive 5x. And last, minus 15. If I combine the middle terms, which are both x things, I get positive 2x. So my final answer would be x squared plus 2x minus 15. Notice how we always write things in what they call descending order, or the general form or standard form, where the biggest power comes first, the next biggest power, and then the last. You will write that on your exam as well. In number 3, our first times first would be 2x squared. Our outers, 2x times positive 6 is positive 12x. Our inners, negative 1 times x is negative 1x. And then negative 1 times 6 is our last, which is minus 6. And I produce 2x squared plus 11x minus 6 is my final result. In the next one, something really interesting happens as we go about our process here. The x times the x produces the x squared as usual. X times positive 5 is positive 5x. Negative 5 times x is negative 5x. And negative 5 times 5 is negative 25. And what we notice is the middle terms, those two like terms, cancel each other out, and we get x squared minus 25. This is called the difference of two squares, and occurs when you see two binomials, things with two terms inside the parentheses, multiply together that look exactly the same, and the only thing that's different is the sign in between them. So you'll notice that they both have an x and a 5, one's plus, one's minus. The middle terms always drop out. The first thing is squared, the last thing is squared. So x is being squared, there it is. 5 is being squared, there it is, and there's always a minus sign in between. Always happens. So that's kind of nice. In number 5, they write it at the binomial being squared as one thing. If it's helpful, maybe we should write it as our two parentheses, x plus 3 times x plus 3, and then, because that's what the squaring means, and then we can FOIL. So now if I FOIL, I have the x times the x, that produces x squared. I have the 3 times the x, that produces 3x. I have the 3 times the x, that's another 3x, and the 3 times 3 is positive 9. And when I combine my middle terms, I get x squared plus 6x plus 9. Okay, so one more time, shortcut. Look at the first term. If you want to use the Joachim shortcut, square the first term, x squared. There it is, the first thing. Look at the last thing, positive 3 squared, positive 9. Multiply everything, 2 times x times positive 3, 6x. That's the term in the middle. In number 6, we have something a little bit different. We have a number on the outside, or a term, I should say, on the outside of a big, long polynomial. In this case, you just multiply each of the pieces. So negative 2x times 5x squared is negative 10x cubed. Negative 2x times negative 8x is positive 16x squared. And negative 2x times negative 1 is positive 2x. This is called the distributive property. And all you're doing is you're distributing the multiplication of the negative 2x on the outside, that term, times each of the terms on the inside. This is a little bit different than FOILing because there's not two terms inside of a parentheses to begin with. In number 8 is very similar to the one we just got done with in number 6, so I'm going to do that one first. In number 8, there's a term on the outside